Welcome to Maths with EJD. In this video, I'll be talking about, I'm just showing you the Python code for graph properties. In the previous video, in the video before this, right, I talked about graph properties actually. Like I went in depth to talk about the degree of of the of a vertex of a graph, you know. It talked about in degree, out degree, talked about path cycles, connectivity, subgraphs, subgraphs can actually be normal subgraphs or induced subgraphs and then complement themselves. So for degree, right, you remember it's the total number of edges connected to a node, indicating the node's connectivity in the graph. So the degree of the node of a graph is actually the node's connectivity, the number of edges connected to it, but to it rather. I mean, but then you have the idea of in degree and out degree coming on when you talk about directed graphs, right? So imagine if it is an undirected graph, a very good example of that would be on Facebook. I mean, Facebook can be both a directed and indirected graph in the sense that if I mean, initially, right, you couldn't follow people on Facebook, but now you can follow people even without being their friends. So when you talk about Facebook friendship, that will be an undirected graph because you cannot be my friend if I'm not your friend. We have to be mutually friends. So that would be an undirected graph. So if I'm a person on Facebook, so that means I'm a vertex or a node. So the number of friends I have is actually my degree of the degree of my degree, right? So to speak, my degree on Facebook. So the number of friends I have, like right now I have like um do I really know? Like I have like 5,000 almost. I always hover around 5,000 friends. I keep trimming it down because I mean, when too many people come on again, and I just try to look for people who are inactive, and then I remove them and all that. So you can say that my degree on Facebook is actually 5,000 because I have like 5,000 friends following me. But then when it comes to in degree and out degree, it's more like when you use the follow feature, which is on Facebook and also on Twitter or now X. Okay, so in degree will be the number of people that follow me, or out degree will be the number of people I follow. So in degree is the number of incoming edges to a node in a directed graph, while out degree is the number of outgoing edges from a node in a directed graph. So then we talk about paths, which is a sequence of nodes where each node is connected to the next by an edge. Okay, so I used an example of a road network, or even it can even be maybe you're flying to let me see, maybe you're flying from Sendai, Japan to say let me see to Orlando, Florida. That's a good example. So you can fly from Sendai to Tokyo, which is still in Japan, and then from Tokyo you can fly to San Francisco. From San Francisco you can fly to Orlando, Florida. So that's like a path because it has a sequence of nodes. So the nodes are Sendai, Tokyo, San Francisco, and then Orlando. Okay. So that's a path. It's a sequence of nodes where each node is connected to the next by an edge. And then you have cycles. So a cycle is actually a path that starts and ends at the same node, forming a loop in the graph. So it's more like, okay, that same trip you went on, if you do a return, if you just go in one direction, that's just a path. But if you do a return trip back to Sendai, like you go Sendai, Tokyo, San Francisco, Florida, Orlando, Florida, and then you now come back, back to Sendai, in that case, that's like a cycle. So that's a path that starts and ends at the same node, forming a loop in the graph. Then you talk about connectivity, which describes whether a graph is connected or disconnected by analyzing the number of connected components. Then you have subgraphs, which is a subset of nodes and edges taken from the original graph, maintaining the graph's structure. And then you have complements, which is the complement of a graph, right, contains all the edges of that graph that are not present in the original graph. So you use the same nodes, but then different edges that are not in the original graph. Okay, that's very close to the idea of the complement of a set. So here now, look at the Python code implementation. I already told you that we have what is called what is it now? We have a library in Python called NetworkX. NetworkX, that is the Python library for working with networks like that. So you can import NetworkX as NX, and then of course you need to visualize using PyPlot. So let's look at the different properties now. In line 4, we have degree, which is talking about in degree and out degree. How do you create that? So you just define. So we are using a Python function now. So where you have def, that's like you're defining a function doing a particular kind of task. So you have define plus degree. Then you want, and the deal is to create a directed graph. And to do a directed graph, there are two types of graphs, undirected and directed graph. If you want undirected graph in Python, you just do nx or NetworkX dot graph. If you want directed graph, that'll be die graph. Okay. So then you now do, so you have defined G to be a directed graph, right? So it means it's going to have arrows. So G, you now add the edges now, A, B, B, C, C, A, B, D, anyhow you want it done. And then you create a layout for visualization, which is, so that would now be POS equals NX of spring layout G. Then you can now plot the graph with labels. That's what is happening from 15 to 16. And that'll be happening for degree, in degree and out degree. And then we also add something extra to tell us the number of degrees and things like that. Then you have the cycle, the path cycles and connectivity. So same thing, you're doing normal graph and not digraph this time around. And then you're adding the edges A, B, B, C, C, A, D, E, E, F, 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 D based on what you have. And inside of that now you have a cycle D, E, F. So and what's happening is you have D, E, E, F, F, D. So back to that D again. So that's like you can already do that as a cycle in the process. In fact, it looks like ABC is also a cycle. So you have A, B, B, C, C, A. So coming back to A again. All right. So you have that. So you can plot it and label and all that. Then you also have subgraphs and complements. So for the subgraphs now you have the graph, and then what will matter is the edges you're adding is what is going to decide what kind of subgraph you have. Then this is the you have a full graph, then you have the induced subgraph, the complement of that. Then you plot this full graph from line 65 to 69. You plot the subgraph and then you plot the complement and all of that. So in lines 85 to 87, now you say plot degree. So it tells you the degree of the degree. Then this one tells you about the, now I mean these are function names you have defined previously. Plot degree, plot path cycle. So you can see this is plot graphs, complements. The other one is that's how you call Python functions. Plot path cycles and you plot degree. So you're just calling forth these ones at this place. So it now tells you the degree of your plot path cycles and all of that. So in a blow, I just click on this and it takes a bit of time and it outputs all those things. So you have degree now. So you have A, B, C, D. So this is a directed graph for sure. So you can see that for A, there is one in. So for A now, the in degree is one, the out degree is also one. For C, the in degree is one, the out degree is one. For So it's like 1 1 all the way, except for D, right? The in degree for D is one, but the out degree is zero because there's nothing going out of D. Okay. Then you also have path cycles and connectivity. So the DEF here is actually a path, a cycle rather. BABC2, just like I said the other time, is also a path here. So you have the components BACDEF. So is the graph connected? So the graph is not connected. Like these two graphs aren't connected. They're just cycles under that. Then you have a full graph, which is this A, B, C, D, E, F here. Then you have the induced graph. That's just a path. So if you extract the ABC part, you have something like this. And then you also have the graph complement. So maybe edges that are not in the original graph. So you can tweak all of these things and get the gist. So I'll stop here. You can just look at Network X and you can play around with it and get some beautiful patterns already. Okay, so there's so much more to come. We're just starting. We are still talking about graphs. So when we are done with graphs, we talk about networks. They are closely connected as I'm taking them together. So it is under networking that you now see the actual application of this graph. Of course, we are seeing that already from the examples I've been given. So hit the notification bell so you can subscribe and hit the notification bell so you can always get alerted each time a new video is released. Then comment, let me know if you want me to teach a topic or solve a problem related to whatever, anything math, Python, bordering on maybe scientific computing, basically, Then of course you want to like and share so that more people can have access to this great content. Till I come your way again, keep networking. Bye.